To round out our understanding of data flow diagrams, we want to talk about some advanced features that are available for you if you want to go off and get serious about doing this sort of notation. So the basic structure we've talked about, we have processes, we have data flowing between processes, but advanced systems does more than just data goes from point A to point B to point C. To some degree, if you want to do an advanced system, you're going to have some sort of user interface, and not every user interface starts with new data coming in. There's event-driven stuff, like hitting a refresh button. There's no data that comes in with that. There's no data that's being passed around. It's just saying, hey, go do this thing again. This thing that I asked you to do, go do it again. And that's what we need to model in the system, as well as some other stuff that comes along. So one of the big challenges we have is modeling static data. Basically, everything we've talked about, and we talked about this wrapping up the last session, is the data sits around resident. It's passed along, it doesn't sit around resident, excuse me. It's passed along from point A to point B. So when we start our whole application, the assumption is that somebody gives us all the data we need, and that's totally not true. We have databases, we have files, we have data we've stored from system configuration when we started up. And so how do we represent that sort of behavior inside of our system, inside of our solution? It's important, it's needed, it's valuable, so we need to include it as we go along. So we can do that using the data store notation. A data store is it's kind of like a box, but just little top and bottom lines. It has inputs and outputs for that data store. So again, you can think of it as a database if it helps you, or a file, or whatever it means. It's just a place data resides. It could just be some memory inside the system. It's just a place data resides until it goes off to be retrieved again. The idea is it is data driven. We have inputs and we have outputs from this. Think of a database. We put data into a database. We get data back out of a database later on. And so it's not something that has its own behavior. There's no modification of the data by the data store itself. Don't get me wrong. Other processes might come in and manipulate that data. It's not to say that when the data goes into the data store, it always comes out the exact same way on the other side. It just is saying that it's a place data stored in the meantime. So as an example, we talked about the wallet example beforehand. You could have a wallet where you go and retrieve money from. The question is who puts money into the wallet? That's a good question here. So let's use a little bit more practical example. So when we have our solution, we get our shopping list, we go shopping, we take that unprepared food, we throw it out there, and we cook the food. The person might not take the food right off the skillet or the stove and put it right in their mouth. So we have a food warmer in there. So as the food gets finished, which again, if you think about dinner in an analogous sense, it doesn't all get finished at the same time. So I have a food warmer. I might have an oven that's set to 150 degrees that just keeps things nice and toasty warm for me once I finish cooking it. So I take that prepared food, I throw it in the food warmer, and then I pull it out when I'm ready for it. In our case, we're using this as a storage mechanism to shift time. Because I'm not going from one to the next, it's not quite ready yet, I'm going to put it there. So you can think of it this way. If you have a process that's buying something, I might be creating an order. I take that order and I put it into the database, which we could classify as the order management system. And then I have another process which later on reads from that database that says I'm going to prepare it for shipping. So it's not to imply, and it's actually being more accurate in your model, that the second I click on buy from Amazon.com, there's a little person who jumps up and puts my stuff in a box and ships it to me. That's absolutely not what happens. It goes to a database, and when somebody logs in for work, they start taking the orders one at a time, they pull them from that database, and they start fulfilling them. And so that's how I would use this approach to model that when we went to a software system. So this is one aspect, the flow of data, but the exact opposite aspect that we also want to consider is the flow of control. So sometimes, as we said, we're going to hit a button and it just kicks the system into action without providing any new data. And so we have the model, which we have the continuous data flow through the system that we saw, but we can also do it where there's a change of control from process to process without any specific shifting of data. Either you've already got the data you already need to work with, or maybe you don't need data to work with, or you're pulling data from a data store, or for whatever reasons. So the type of data being sent might have big impact on the functionality. I could theoretically still send control data that doesn't necessarily change the output of the functionality. It's just, hey, how it's going to work. So the control versus continuous, you don't have to be too exact inside of that. You basically want to use it in mechanisms where it's telling your story better off. So the way we see it inside of there, and this is where we went back to, we talked about the importance of drawing the right lines before. A control flow is a dotted line. So from process A to process B, we have an arrow with an arrowhead on it that has a dotted line instead of a solid line that shows the change of control. What we're saying is that one procedure finished and is calling another procedure, essentially. That's at the code level, that's how this would appear. But again, we can model this as code or we can model this as business process. We could say that, hey, when the shipping happens, the hospitality team will send you a reminder that a new sale is coming up the next day. So it's not based off of you per se buying some specific thing. I don't even know what you specifically bought. Just the fact that you bought something means you might be more likely to buy something again right away because you're so wonderfully shopaholic that you can't stop yourself or something like that. There's some strategy to that people shop more or something like that, but I don't understand it. But again, it's a control flow. It's not, hey, thanks for buying toilet paper. Now would you like to buy a car? It's basically saying, hey, thanks for buying stuff, and here's some more stuff you might want to do based off the sale we have going on. So here's an example from the domain we've been working on. A little bit abstract, but it's actually very fair. So when I go shopping, I could actually go to certain processes and say, hey, preheat the oven, or hey, set the table, because that way it's ready when I get down later on, when I want to go eat food. Now, whether I'm calling the exact same processes or whether I have procedures and something more detailed, I mean, I might not be calling the eat food directly. I could be saying like part of eat food is having a set table, and I can do that asynchronously. So you can go off and do that. So there could be a suite of code that's being called. It's conceptual here. In a exact design, I should be calling an existing procedure or function in my system. So I probably would have to say prep table, and that prep table would then be called somewhere within eat food that would be, or at least the results of it would be stored and, for eat food when I would go off and do that. Like again, when I'm going to go cook the food, if I have a preheated oven, I can jump at it right away instead of having to wait around as much. So that's conceptually what we're getting to. So you can use, if you have it appropriately, control flows and data stores. I'm not expecting you to use them per se. If it makes sense for you, if it tells the story better as part of your data flow diagram, use them. If not, then that's okay. All right, so that's the core of what we want to talk about here with the structured design and the data flow diagram. We'll have one more session here to kind of wrap it all up and kind of talk about it and make some choices of whether this is what you want to use or not. There'll also be some examples of putting this stuff together in a little bit more detail. So again, now's kind of the time to think, based off the next session, what you want to do for your design. So give that a thought. Come back, look at the last session.